Okay, so we're going to continue on with section 4.1, and let's go back to example 2 and 3. What do we know about the graphs of f of x equals 2 to the x and g of x equals 1/2 to the x? So let's go back to example 2 and 3. Okay, so example 2 looks like this, and notice how the graph looks like that. It goes to 0, 1, I have 1, 2, and so on. I'm going to get there. And then example 3, note that 0, 1, I have negative 1, 2. Okay, so let's kind of look at that carefully. And if I were in class, I would actually do this, and I would put them on top of one another on an overhead. But just kind of looking back at the graph, and you can look back at your notes. You're going to notice that the graph of 2 to the x looks like this. And I had 0, 1, and I had 1, 2. So let's draw a little better there. Draw it again. So I had I had 0, 1, and I had 1, 2, and I had 2, 4, so it'll be up here somewhere. And I had negative 1, so on, and then so on. So it looks like this. That was a graph of f of x equals 2 to the x. And we had a horizontal asymptote of y equals 0. And then we looked at the graph of 1/2 to the x. It went to 0, 1 also, but at the negative 1, 2, negative 2, 4, and so on. And it has small points down here. This is a sketch, not the grade graph. We have g of x equal 1/2 to the x, which is the same thing as 2 to the negative x. We discovered that. But do you note that there's actually a reflection about the y-axis? This is the same thing. This, and again, the asymptote is still there for the 1/2 to the x. Okay, but you note that the reflection across the y-axis is the mirror of the y-axis. It shouldn't surprise us because f of x equals 2 to the x and g of x equals 1/2 to the x, which is the same thing as 2 to the negative x. Do you notice how I took x and replaced it with a negative x? If we go back to our transformation, that basically says that we're going to have reflection across the y-axis. Okay? That should not surprise us. Okay, so let's go ahead and look at some characteristic exponential function. These are going to be true about any exponential function in the form of f of x equal b dx. You can always have a domain from negative infinity to infinity. X can be any number. Okay, so we're going to have that domain. The range is going to consist of all positive real numbers from 0 to infinity. You're going to notice in all the examples before, our y value, it never reached 0, but 0 was our endpoint. It got close and close and close to 0, but never reached 0. That's why we didn't include 0. And then it always shot up, and the y value went higher and higher and higher. So our domain range is always going to be the same. Every graph is going to go through 0, 1, because when you put 0 in, doesn't matter what the base is, say 3 to 0, 4 to 0, 5 to 0, it doesn't matter what the base is, as long as it's positive, not 1. Sorry, 0 here. Any value to 0 power is going to be 1. So 0, 1 is always going to be a point. It's going to be the y-intercept. There's never going to be an x-intercept because that's how all these graphs never cross the x-axis. Okay? They're not x-intercept. If the base is greater than 1, that's like 3, 4, 5, it's going to go up to the right. So it's going to look like this right here. Here the base is greater than 1 right here with each example. And notice how in both graphs they shot up to the right. Shot up to the right. Okay? Now if the base is less than 1 but still positive, right? So if the base is less than 1 but still positive, and I think they mistyped this whenever I put my or perhaps it should be if it's between 0 and 1, so it's got to be more than 0. They'll probably fix it in my next edition, but if you have an older edition, put that 0 in there. The base has to be between 0 and 1, so it's like a fraction, like 1/2, 1/3, 1/4, and so on. The graph is going to go down to the right. So here we have two examples where the base was between 0 and 1. Here's the 1/2 between 0 and 1, and the 1/3 is between 0 and 1. Notice how it went down. I go down to the right. Down to the right. Okay? That's always going to be true about these. It's going to be a one-to-one function, so and has an inverse of the function. So if we do the vertical line test and the horizontal line test, so we know the function because it passes the horizontal line test. Let's go to this one right here. Okay, function because it passes the vertical line test. It's a function, so every line that goes up and down only touches one point. You do the horizontal line test, we know it's 1-to-1. It has the inverse function. Okay? What else do we know about these? We know that it always approaches but does not touch the x-axis. The x-axis, or y equals 0, is a horizontal asymptote. We've been drawing those the whole time. Okay? So this is when the base is between 0 and 1. This is when the base is more than 1. Okay? So now that we know that we can do transformations on these, because we already looked at the x and negative x for the exponent, all the transformations that we've done before are still applicable. So if you add a number at the end, it goes up and down. Add a number to just the x, it's going to translate it left or right. Put a negative in front of the entire function, it's going to reflect across the x-axis. Put a negative with the x, it's going to reflect across the y-axis. We just looked at this one. And then the vertical structuring. We probably won't do that in this section. It's a little bit too much involved. Excuse me. So let's go ahead and do example 4. And let's go ahead and graph f of x equals 3 to the x. And then we'll use that to obtain the graph g of x equals 3 to the x plus 1. This is where we already made a table in a previous example of this graph here. Here's why I taught students that you can probably make this table in your head. Just save yourself some time. So if I actually were to make a table and I put 0 in for x, 3 to 0 is 1. So 0, 1 is the point. We should already know that based on the characteristic. So go ahead and make 0, 1 there. I'm going to label 0, 1 here because I don't have a table. If I put 1 in here for x, I get 3 to the 1, which is 3. So 1, 3 is another point. And then if I put 2 in here, it'd be 9. 3 squared 9. So 2, 9. Now, if I would look at values here, if I put a negative 1 in here, that'd be 1 over 3 to the 1, which is 1/3. Right here. And then likewise, if we do the 2 be 1/9, the negative 2 be 1/9, and so on, we have that little pattern there. Let me go ahead and label that one point there. This would be negative 1, comma 1/3. And then my horizontal asymptote going to be y equals 0, because it will never reach 0. No matter what negative number I put in here, you'll end up with a denominator that's going to be a large number. It just gets smaller. The value is smaller and smaller. Now we see this x plus 1 here. I'm adding 1 to just the x. That means I'm going to shift it left or right. The plus 1 means I'm going to shift it to the left 1 unit. We did that in the last chapter. So all these points are going to shift to the left 1 unit. So this 2, 9 is now going to be 1, 9. This 1, 3 is going to be 0, 3. This 0, 1 is going to be negative 1, 1. And this negative 1, 1/3 is going to be negative 2 and then 1/3. The horizontal asymptote also shifts to the right 1, but that doesn't change that value or that line at all. trying to draw on the iPad. If I get, oh, there we go. Get that point there. This would be 1, 9. This would be 0, 3. This would be negative 1, 1. And then I just had a couple points there. This would be what? Negative 2 and a third. I'm more concerned that you label the points on this one right here, and then I can see that you shift to the left one by looking at your graph. Okay, so on your own, go ahead and use the graph of 3 to the x to obtain the graph of 3 to the x minus 1. So go ahead and do that, and I will pause the video while you work on that. Okay, so here's my graph of 3 to the x, and I made sure to plot or graph the horizontal asymptote. Make sure you do that when you take your test. And here are 1, 2, 3, 4 points. And then I shifted everything to the right 1 unit because I have minus 1 on the x. So here are all my points there. And again, the horizontal asymptote shifts to the right 1, but again, that doesn't change that at all. Okay. Let's go to this next graph. Let's graph f of x equals 2 to the x, and we'll obtain the graph of 2 to the x minus 3. Okay, so again, we're going to go ahead and look at, I'll make this graph here, and we've already done this, but I'm going to make the table in my head. So I'm going to get 0, 1. I put 1 in here, I get 2, so 1, 2. Put 2 in there, I get 2, 4. I put 3 in there, I get 8, and I have run out of room there, so there's not enough room for that. I put a negative 1 in there, I get 1 over 2 to the 1, which is 1/2. There. Okay. And then I would get smaller values, I get 1/4 here. Let's go ahead and make our graph there. Oops. Okay, horizontal asymptote right here. Okay, label points 2, 4, 1, 2, and 0, 1. Again, do you see why I'm labeling these points? Because I don't have a table with points, so I'm going to have to label a couple of these points. And this will be negative 1 and then 1/2. And then I have this one here, but I'm not going to label that one. Just a couple points. And this right here, I have a minus 3 at the end. That means I'm going to shift down 3 units. Okay, so I'm going to shift down 3 units. I'm going to take all these points and shift them down 3 units. Let's go down 1, 2, 3. So now it becomes 2, 1. This shift down 3 units, so it becomes 1, 2, 3. It becomes negative, 1, negative 1. This shift down 3 units, so it becomes 1, 2, 3. It becomes 0, negative 2. This shift down 3 units, so 1, 2, 3. It'll be right there. It'll be negative 1 and then 2.5. And then actually this horizontal asymptote shift down 3 units too, so it goes down 1, 2, 3, so now becomes right there. So it goes right here. Now this equation is going to be y equals, and it's going to be y equals negative 3. And I didn't graph this point here, but this would have been 3, 8. If I go down 3 units, it would be 3, 5. That would give me a lot better graph. So 1, 2, 3, 4, 5. Okay, this is going to be my new graph. And I'm going to label a couple points here to be 3, 5, 2, 1, 1, negative 1, and then 0, negative 2. This would be negative 1, and then negative 2.5. Again, you don't have to, if you don't want to deal with fractions, just label in the points here, it'll be fine. Okay, so on your own, go ahead and use the graph of 2 to the x to obtain 2 to the x plus 1. And I'll go ahead and pause the video and then restart it, and you can check your answer. Okay, so here's my graph of 2 to the x, and I shifted everything up 1 unit. So here are my points. And I went ahead and labeled the point here. If you don't have labeled fractional one, if you don't want to deal with it, but I have, that would be a negative 1, oops, negative 1, comma, 1 and 1/2. Okay, that's the end of this part. I didn't finish this section, so in part 3 we're going to continue on with 4.1.